we'll start by taking a look at the current challenges with blockchain development and some of the friction points that exist today. We'll then get into Blockmason Link, highlight some of the benefits there, and then actually do a live demo of using Link both to interact with some basic smart contracts and then show you how you can actually go about creating your very own ERC20 token with just a few clicks using Link. So let's talk about some of the common challenges faced by end users that are interacting with decentralized applications or DApps. And if you have had some experience in the blockchain space, you're probably quite familiar with some of the pain points. So think about the common sort of experience at the moment. If you want to interact with an Ethereum-based decentralized application, you need to go and acquire crypto like Ethereum from an exchange, save it into your browser wallet like MetaMask, and throughout that entire process, you might be asking yourself, is this process secure? Ensuring that you're able to copy and paste wallet addresses between exchange and MetaMask securely, having to remember a PIN and mnemonic, ensure to make sure that you're able to access your account. So there's all these friction points that exist in terms of interacting with a decentralized application. And let's just take a quick look at what that experience looks like. I'm going to go to DApp rankings here, and we're just going to take a look at my Crypto Heroes, which is the top ranked game currently on the Ethereum blockchain. And if I go to their website here, let's just see what the experience is like for an end user. And so the first thing that I have pop up here is a request to access MetaMask. If I don't enable this, I mean, you can see that there's a lot of information here that I don't even get access to in the first place. And so if I do log into my MetaMask account, then immediately I'm prompted with this connection request from this game to connect to my account. There really isn't a lot of information about what information is going to be accessed. And if I'm relatively new to the crypto space, this immediately throws me off because now I'm being requested to provide access to my account. MetaMask makes it pretty clear here that the site's requesting access to view your current account address. Always make sure you trust the sites that you interact with. But immediately I'm sort of left with the impression that I have no control over what data might be presented to this game. And this is pretty common of most decentralized applications at the moment when you try to interact with them over the web. So let me just cancel that. And if we take a look at the challenges faced by developers, some of the similar things that we talked about with respect to end users apply also to developers. So having to go to an exchange and acquire crypto, having to work with those exchanges, wallets, transactions. But then there's also a whole other dimension of challenges where they need to work with specialized libraries like Web3, and organizations like Truffle have done a good job sort of building out these frameworks that make it easier to use, but there is still a bit of specialized skill that's required in order to be able to utilize some of these big heavy libraries. If you're not a blockchain developer, you have to learn a specialized blockchain language like Solidity for Ethereum, or if you're using a different blockchain, there might be another custom language that you need to learn. And if you think about all these friction points again, developers are spending time and effort on building out infrastructure that actually isn't even really key or front and center for what they want to build. They're spending and having to spend a lot of time investing effort and resources on infrastructure, which doesn't actually directly deliver value to the end user. And that's something that we want to tackle with the applications that we build here at Blockmason. So let's have a look again at the DApp Radar website here. And what I want to point out here is just taking a look at some of the utilization numbers with respect to some of the popular dApps. And so if we go back to our DApp ranking page here, we can see that if we were to rank this based on users over the past 24 hours, that if you take a look at sort of the top 3 or 4, you've got a few thousand users, but then it drops off quite quickly, where the top 10 here, you're starting to get to less than 500 active users. And so this brings about a point around the adoption and retention of users with respect to decentralized applications. And while there might be a lot of applications out there, not a lot of them have many users on a regular basis. And so there's definitely, again, looking at sort of our experience when we first went through and tried to access the Crypto Hero site, there's probably some friction points there that prevent users from actively using the decentralized applications in sort of a regular and meaningful way. Okay, so let's take a look at, and so if you wanted to compare it with the top Android apps, this is just a stat from April 2019, and you can see the sheer size of downloads. And if you were to translate them into active users, there's, the focus is predominantly on downloads here, but you can see that the actual numbers from these centralized applications vastly outnumber the usership on the decentralized apps at the moment. So there's definitely that room to grow here for those decentralized applications. We've seen over the past couple of years, particularly from 2017 and 2019, an explosion in the number of smart contracts that have been built and deployed. And taking a look at the fact that the vast majority, almost 95% of these smart contracts are called fewer than 10 times. And so what, again, this highlights is, there's interest in developers, prototyping or trialing and creating some smart contracts at the beginning here. But in terms of regular use, we see that the vast majority of these smart contracts aren't even being used. There's also a survey that was done with about 2,000 developers, taking a look at the state of the blockchain. And this is just to give folks here a sense of the relative optimism that developers still have with respect to blockchain tech. Over 80% presented a positive view, 50% of them learning blockchain development for their own personal interest. And there was still about 10% of survey respondents that said they're not interested in blockchain. And some of the reasons why that's the case is, everything from still being early days and it being a bit of a fad, to really asking the key question, is blockchain even useful? And what are the benefits and where should I use that particular tech? So we see there's plenty of initial end user interest and developer interest, but there's still barriers to mass adoption and retention, as we saw based on the usage numbers from some of the popular decentralized applications. And so the question then arises, how do we sort of tackle those friction points, and what are we able to do and build that makes it easy for developers to build their applications? It's probably worthwhile just to quickly even highlight why even use blockchain. And this industry, currently has this challenge where blockchain, being the buzzword that it is seen as a solution, looking for a problem to solve. You can think of it as effectively a hammer that's looking for a nail to hit. And so there are some tangible benefits with using blockchain, and some of the common ones that you might be familiar with are presented here. But the key point to take away here is that the benefits provided allow for developers to focus on things that actually deliver value for their end users, and not having to spend a lot of resources dealing with the underlying infrastructure. And this is why hosted solutions like AWS are quite popular. Blockchain is one of these sort of hosted solutions here where there are some tangible benefits that can be used by developers.
Yeah, and to kind of add on to that, if you've ever tried to spin up a web server or a web API or a website that has some sort of state that allows people to record information that sticks around for any period of time, that excuse me, that has its own set of complexities. That's kind of a difficult process, and that's something that sort of AWS and infrastructure as a service stuff is, trying to solve, to some degree. And blockchain can be a solution to that. But as you saw earlier, working with a blockchain as a developer, there are a lot of hurdles there as well. So on one hand, there's difficulty in working with and dealing with web infrastructure. And on the other hand, you have the sort of difficulty in working with blockchain. And that's kind of where Link comes into play.
Awesome. Thanks, Devin. So let's take a look at Link, what it is and why we think it might be a solution to address some of these challenges that we just went over. So Link is effectively the first managed decentralized functions as a service platform. And the goal here is really to push the envelope of interoperability. Link does this by creating conventional web APIs for developers to interact with networks such as blockchains, with the goal of empowering developers to really get them to focus on creative innovative projects, and getting those projects to market as quickly as possible. And so we see Link being able to open up an entire new population of users and clients to the growing world of decentralized applications, and effectively expanding beyond this pool of early adopters. Other players in the sort of fast space include the likes of AWS Lambda, Google Compute, but those are definitely designed with vendor lock-in in mind. They can be heavy, complex solutions, whereas Link is effectively this thin application that's easy to get up and running, and provides the convenience and familiarity of conventional web APIs. And you're essentially only utilizing the compute power needed to run your key functions, as is the focus of a functions as a service platform. So we've talked about some of the benefits of blockchain in general, and we've introduced Link. Taking a look specifically at what Link has to offer, whether you're building a new application or using an existing one, whether it's web-based, mobile-based, Link makes it very easy to integrate blockchain tech into your existing stack or a new stack if you're building a new application. If you actually go to our blog, we outline how we took an online game from 1997 and retrofitted it to use blockchain to be able to track those digital assets that you're able to trade and exchange in that game. And so that kind of highlights the resourcefulness of a tool like Link to be able to take something that's relatively old, or a tech stack that might be a little bit old, and being able to pull in a new piece of tech into it. And so again, the focus being on being able to provide tools for developers to help them get their products to market as quickly as possible, not really having to spend a lot of time on back-end infrastructure.
Yeah, and to kind of elaborate on that a little bit, like when you're building an app that interacts with a blockchain, there's a lot of complexity you have to introduce on the client side. There's a lot of cryptography you have to incorporate into that, and it's just a very difficult thing to bring into a project that you already have. Whereas if you've ever worked on any software project professionally, you've probably had to call a web API at some point, and you probably already have a tool for that. And so our goal here is to allow you to use something that happens to have a blockchain underneath it but to have that look and feel just like any other web API that you've already interacted with before. So easy, you already know how to use it, I guess, is a way to think about it.
Awesome. So just highlighting this in terms of where we've sort of focused our efforts so far on integration. So there is a Link private blockchain that we've got built into the Link application, which just is effectively our parity nodes. And then we've also integrated with Ethereum. So if you wanted to use any of the Ethereum test nets or the main net, you're able to do that directly through Link. Here are some of the other chains that we've looked at and are working out ways to actually integrate into the Link application. The goal for us really is to be chain agnostic. It really shouldn't matter what chain you've got under the hood. And the beauty of Link, really, which we'll see in just a couple of slides here, is being able to pick and choose features from different blockchains depending on what kind of application you want to build. So maybe there's a need for privacy and you want to keep certain records on a private blockchain. So you might use the Link private network, but maybe you want the transaction and the payment layer to be made public. So you could use the Ethereum blockchain for that. Essentially, because you're just using web APIs, you're able to program this relatively quickly using the tech stack of your choice. Okay, so we've done a fair bit of talking here. Let's actually go through the process of creating and deploying a smart contract using Link. So this is leading into our live demo here. So I'll start by just pointing out that you can access Link by going to the website blockmason.link under get started. And when you register and set up your Link account, this is the interface that you land in. And here's basically an IDE where you can, copy and paste some contract code from templates. If you do have some Solidity experience, you can actually build out your code here, similar to what you might do with using Remix, for example. And you see this toggle here. So effectively, as you're writing your Solidity code, in real time, this code is actually being deployed to the Link private network. And so by clicking on the API, you get to see the API endpoint that you now have access to. In this case here, it's just a simple GET request to this hello world function. And this function is effectively just returning a piece of string back. And so we've built out an SDK, a JavaScript SDK, along with a .NET SDK that we used for the online game integration. And it's super easy to go and install this into your existing project by pulling in this particular node package. And then there's a bit of information for how to actually configure it to be able to then go ahead and use this in your application. So if we want to take a look at a very basic piece of code and how this is being used, let me just pull up the demo. So this is just a simple JavaScript file here. We pull in the Blockmason Link SDK for JavaScript, and then really the two pieces of information that we need to pull into creating this Link object is the client ID and the client secret. And this is effectively how your application authenticates with the Link platform. No different than getting an API private key that you would then have to use when you make your API request. And this client ID and this client secret, you get that from the bottom here. So those are the two pieces of information that you need to use to access and make those API requests. And so all we're doing is we're wrapping this in an async function here. All the requests here are async. And so we'll literally just run our little node command here. And we should see that we get back our string hello world. So we just made an API call to a GET request to this endpoint, and we got back the message that we would expect here. So that's a pretty simple example. Let's look at something a little bit more complex here. So in our GitHub repository, we actually have a template for a few different contracts. And so I'm just going to take a look and see if we've got this ownership contract. So this is a very simple contract that effectively records ownership of a particular asset. So I'm just going to copy that template and paste it into our IDE here in Link. Yep. Let's just do that again. Okay. And so just taking a quick look at this, you've got a mapping here between a string and address in an object called owner of, and this is effectively the database that records a string being the asset and what address owns that particular asset. There's an authority that's the owner of the contract as part of the constructor. And then we've got a very simple emit event here that we won't necessarily get into here, but you basically, every time you basically set the ownership, you can capture these events and using for logging purposes. So once we've got that, it might just take a few seconds here to update, but we'll be able to see our API endpoints here. There we go. So we've got our set owner, get owner of, the authority, and then our event if we wanted to pull that. And again, this is all being done sort of in real time. As we're updating our code, it's being deployed to our local Link private blockchain, and these API endpoints are being populated. Every time you change the code, because it's being deployed, and when you deploy something to the blockchain, it's immutable, you'll see that we actually update the client ID and the client secret that's used to authenticate to access the particular contract function. So I've also got another script here where we're basically doing a couple things. So in this ownership script file, again, we need to populate the ID and the secret accordingly, but we're just going to do two things. We're going to set the owner of some asset, some painting with a particular address of the owner of that asset. And then we're going to retrieve the owner by passing in the name of the asset. And we should expect to see the owner's address being returned here. So I'm just going to make sure I get the right client ID. And get the secret. Okay, we'll save that. And now let's run this. Oh, did I not? Let's see here. Just needed to update with the correct client secret here. So let's save that. And let's try to run this again. Sometimes you just have to refresh this a couple times just to make sure that the client ID and the secret sort of stick as we're kind of doing this in real time, updating the contract and deploying it. Sometimes the client ID and secret don't refresh fast enough here. So let's just try this again. Okay, so we set the ownership of that particular asset, and then our subsequent function here, we were able to get the asset by passing in the asset name. And so here's again a very simple example of being able to use APIs to interact with the blockchain to record ownership of a very basic asset. And just to highlight, what this could look like in terms of an application front end here. So we're kind of doing this on the back end here using Node. But if I were to show you an example of what a front end application here looks like, you could have any sort of collectible digital asset. CryptoKitties is a very popular example of this in the blockchain space here. But if you remember our first experience with the decentralized application, where we were asked to open up our MetaMask wallet and then have the application authenticate with it, we've kind of taken away all of that that sort of friction and that particular sort of unease experience by just allowing this application to interact with the blockchain using web APIs. And so, for example, if I just wanted to set the ownership of this particular piece of that digital asset, I can go ahead and do this. I guess I'm not logged into it, but you kind of get the picture here, where the experience here is vastly better than what we had before, where you had to go through a third-party application like a MetaMask browser wallet to be able to then interact with this. And so you can imagine, going to these websites and maybe having to, you could in the conventional way, pay to use the application using a credit card, and then behind the scenes, that credit card could maybe translate into whatever crypto payment that's required to process the API requests. But on the front end, from the end user's perspective, it looks and feels like any other application. Okay, so that was our example of deploying a smart contract using Link. Let's actually go through the process here of using Link to create and deploy your very own ERC20 token. And so we actually put a post together on this where we walk through the details of being able to create your token. And because in this case here, we're using the Ethereum network, we're going to do this on the testnet, the Ropsten testnet. The process within Link is a little bit more involved. There's a few more pieces of the puzzle that you need to pull in. So through Link, we actually access the Ethereum network using Infura. And we've got basically an Ethereum account, a hosted account that pays for the gas transactions. If you're familiar with any sort of blockchain development, you know that there's usually a gas fee that's required to be able to post things to the blockchain. And so in this case here, you'll have to seed this Ethereum account with a little bit of test ether, and you can do that from this Ropsten test faucet to drip a little bit of ether to your account. But apart from that basic setup there, actually going through and deploying your contract and deploying and creating your own ERC20 token is actually quite straightforward. So again, we've got a smart contract template for building out your own tokens. So I'm going to copy and paste this from our template. And for those of you who may not be familiar with what an ERC20 token is, there's a wiki here that you can take a look at on your own time. But it's basically just a standard interface for creating an Ethereum-based token. And so it sort of dictates the types of functions that you need to have, as well as the number of decimal places, the symbol, all of that sort of defined in an interface to maintain some sort of standard as tokens get minted on the Ethereum network. So let's go back here. We're going to create a new project, and that was the demo that we just showed there. But we're going to create a new contract, and so this is going to be, let's call this our CryptoChicks token here. So and in here we're going to paste our token contract. So a lot of the functions that I mentioned in the ERC20 standard are included here as are elements of safe math. Some of you might be familiar with that library, but basically ensuring that when you're minting your own token and you're doing some basic math on it, that you're not running into some of the common problems that you have with the types of objects that Solidity use. So won't get into too many details there, but basically all the elements of the safe math library are incorporated into this token template. So let's use the abbreviation here, CCT, for CryptoChick token, and that's what we're going to call this. Token, CCT. This is, again, part of the default for ER20 token standard. And then we really just need to have a wallet address that's going to be the treasury. That's actually going to be the one that receives the entire supply of this new token that we're about to mint here. And so I'm just going to take an address that I've got. And the last thing we need to do here is specify what our supply is. So the default in this template is 1,000. Let's make this 500,000. So all of that, the new supply of this token that we're creating, this 500,000 tokens of the CryptoChicks token, is going to be minted to this address that we're setting as the treasury. So let's go ahead. We'll save this. And then we'll go through and actually deploy it through Link here. So let's use this contract. The default account is this the hosted wallet that Link has. So we'll just use that. We're going to use the Ropsten public test network, and we're going to use Infura, our connector from Infura. If you're not familiar with Infura, essentially when you sign up with an account, this is what the dashboard looks like. And if you create a new project and you take a look at these endpoints, this is how you can use Infura to actually connect to the Ethereum network. And so you can choose what network you've got, and then these would be your endpoints. So right now we're going through the process of deploying our custom token to the Ropsten test network. You could effectively do the exact same thing on mainnet by just using the appropriate endpoints. So in this case here, it'd be the mainnet endpoint. You would also then have to make sure that on the mainnet you seed your Ethereum account with a little bit of Ether in order to pay for the corresponding gas fee. Where's the contract deployed? So our contract isn't deployed, so we're not going to be specifying an address in here. And we're going to call this our CryptoChicks token deployment. I'm going to use the default Ethereum account. That's the contract, and that's the network that we want to deploy this on. So we're ready to perform this deployment. So again, just check the account, the contract, and the network. And then because this is the public account, it might take anywhere from 30 seconds, maybe up to a minute to actually deploy this. In the meantime, let me just show you a couple other things here. So this wallet icon here, this is where we can actually, see our hosted wallet. And if you copy this address, we can now use the Ropsten Etherscan to be able to check the details of our wallet, as well as the contracts that get deployed. So that's my current my current wallet, and you can see it's already updated here by highlighting that 31 seconds ago this new contract was created. So let's just actually go back in here and see that this was indeed deployed. So Ethereum contract deployment, there's our CryptoChicks token deployment. That's the address that it's actually deployed at. And so we can see, double check that the status is indeed that it's deployed. And so this address here should match the address that we see for this this contract that was created. And there we go. Our new CryptoChicks token, we see that it was just created here. And we've got our token supply of 500,000 CryptoChicks tokens that are all minted to this one address that we, if you remember, we specified as the treasury for this new cryptocurrency token. And then the last thing I'll do is actually add this into my MetaMask wallet. So I just need to copy the contract address. So MetaMask knows what contract I'm using. Just make sure you're also on the Robson test network. And this address that I used was actually this account here. So right now, I don't have any CCT tokens. So let's add that token. And it'll be a custom token. We specify the token address that we just copied from here. We see it automatically populates with the token symbol and the precision. And then I can see there's my balance of the 500,000 CC tokens that I just created. And I can add that, and there we go. I've got my newly minted 500,000 tokens that I can start sending to all my friends because I know they'd love to receive this. But that's essentially it. With a few clicks, we were able to deploy our custom token on the Robson network. And again, if you wanted to do this on mainnet, you just ensure that this wallet address here has got a little bit of Ether on the mainnet to be able to pay for the gas fees. And then if you use the mainnet Infura URL, you'll be able to do the exact same thing and deploy your custom token onto the mainnet. So that's the demo. We've hit about 43 minutes here, so I know we covered a lot of stuff here. So let's pause and park it there and open it up for any questions that anyone might have. Russian, I've got you unmuted there.
Can you hear me?
Yep.
I have a question about the MetaMask. So if your wallet is MetaMask and you use your address from that in the Link platform, whenever you make a transaction, normally when you use MetaMask, it usually pops up and asks you to confirm a transaction. Will it do that, or it doesn't do that?
So the link address, this address here, will basically make those transactions on behalf of the application.
Oh, okay.
So you as the user, again, the idea is that we're trying to abstract away all those sort of friction points. So for example, even if you're doing a transaction that didn't involve you sending any money, you're still prompted with that MetaMask confirmation.
Yeah.
And we're basically trying to minimize those friction points. So yeah, you won't see any of that. Of course, if you're actually sending some real crypto between accounts, you would effectively design your application so that you do have a couple layers of confirmation to ensure you're sending it to the right address.
That was my next question. So if you have an app where they're taking 1 Ether, for example, it requires 1 Ether from the account. But if you're not using MetaMask, it would just be up to that person to know that they have 1 Ether, and when they put in their address, that's going to be subtracted, rather than MetaMask where it's more visual, Yeah,
you would effectively be building out sort of a similar confirmation process there.
Okay.
But the beauty there is you can actually build out your front end apps where maybe you're transacting in fiat, and behind the scenes it gets converted to Ether, but the end user doesn't even need to know any of that. They won't even see it.
They just put in their address and it just takes it from there.
Yep.
Okay, cool. Thanks.
Thank you for your question.
Yeah, and I'll elaborate on that a little bit. So Link makes it to where you can say, for example, create a game that people can play online, right? But in terms of accepting payment from that person, if if your customers, if the people that you expect to be paying you to play this game or whatever it is that you're providing, if they already have crypto wallets and they're already dealing in Ethereum, then you might as well just integrate directly with the Ethereum network and use Web3 instead of Link, because those people already are used to it. They already know how to use MetaMask. And on the flip side, a lot of people out there don't even know what a crypto token is. They don't have MetaMask installed. They've never dealt with that before. Maybe they're afraid of cryptocurrency, whatever. Like, there are many reasons, and it's still kind of a new emerging technology. So something like Link would allow you to build software that people that don't know anything about blockchain can use, and they can pay you using some non-blockchain thing. They can use a credit card, and you can use a company like Stripe to handle those transactions. And that way, if you choose to use blockchain as a technology choice to build your app, your users don't have to agree to that as well. You can make that without affecting them. So it kind of decouples your technology choices from the user experience of what you're building.
Awesome. Just taking a look at the group chat here. So I see there's a question from Artem around which address must pay for the gas fee. Is it the individual, or is it possible for the smart contract or another wallet to pay for this fee? And so effectively what we're seeing here with Link is that this is an account on it could be on the developer's behalf that is paying for the gas transaction fee. So the end user doesn't actually need to be the one paying for that gas fee. If you structure your application where let's say the end user maybe pays a subscription fee to access your service, behind the scenes you've got this hosted account that's actually taking care of paying for those gas fees. So you can definitely decouple the action of having to cover the transaction costs by having the Link hosted wallet doing that job for you, if you want to keep it a sort of a more streamlined experience for the end user. Do we have any other questions? Okay, well, if there are no more questions, let me just thank everyone for taking the time for coming out here. There are a few links highlighted here where you can follow along with the Link development. You can also reach out to us through these channels if you've got any other questions or want to interact with Link and keep up to date with the development that we're progressing with here. And also a big thank you to Lena for setting us up and working with us. And we're excited to have this partnership with Crypto Chicks. We do expect to be running more of these webinars. We'll kind of take what we covered here and build on it. So doing something like, a collectible digital asset application where you've got both a recording layer that's being done on one blockchain and a payments layer that's being done with a different blockchain like Ethereum. So you can kind of see the full functionality of a tool like Link that allows you to interact with multiple blockchains and be able to take the benefits of the features that exist for different chains. So we'll intend to set something like that up relatively soon. But on that, thank you so much. Enjoy your day or evening or wherever you may be. And thank you again for attending.